Okay, you're probably thinking, why should we study chemistry since this is a biology class? So if you remember back when we talked about the levels of biological organization in Module 2, remember that we started with the bottom level, the atoms, and then when we put the atoms together, we get molecules, and then we put molecules together to get even bigger molecules, the macromolecules. And then we put those together to get organelles, and then we keep going up the levels until we get to the organisms, and then we can go further up from there as well. So we need to study chemistry because each level will build upon the level below it. And so the way that the organ systems and the organs and tissues and cells, how all of them work actually depends on the properties of the atoms and the molecules. So that's why we've got to spend a little bit of time on chemistry in a biology class. So let's just take a look at a few definitions here. We've got matter, which is just anything that takes up space and has mass. And you can kind of think of mass as like weight. And all matter is made up of elements. And an element is just a substance that cannot be broken down into other substances by chemical reactions. So for example, if you have a gold coin, that gold that's in the coin cannot be broken down into any other elements. Okay, so it's just gold. So gold would actually be an element. And each element is going to be represented by a chemical symbol. So the chemical symbol for gold is actually AU. And a lot of these chemical symbols, they actually don't make sense because you're like, AU for gold? It actually comes from a Latin term for gold. So that's where the AU came from. All right, let me give you another example. So water would not be an element because water is actually made from hydrogen atoms and oxygen atoms. So you could break down the water further into hydrogen and oxygen atoms. So water itself would not be an element. But the hydrogen and oxygen, those would be elements themselves. Okay, and then a compound is just a substance consisting of two or more different elements that are chemically bonded together. So some examples I have here are sodium chloride, which is salt, and then we've got water, would be another compound. Okay, we're going to be working with this periodic table of the elements. And you can see that each of the elements here is given a chemical symbol, which could be a single letter or it could be two letters. So, there's a number of them here that you can look through. And with this periodic table, we're going to be looking at this later, but on the top we've got the atomic number, and on the bottom we've got the atomic mass or atomic weight, which we'll be looking at as well. Okay, and then I would also star this in your notes to know for the exam. So which four elements make up the majority of most organisms? So the way I remember this one is I just remember honk with a C. So not with a K, but with a C. So honk stands for hydrogen, oxygen, nitrogen, and carbon. So those are the four elements that make up like 96% of our bodies. And that's the same for the majority of most organisms. So they're going to be made up mostly of hydrogen, oxygen, nitrogen, and carbon. So if you just remember honk with a C, not a K, those are the four elements that make up the majority of most organisms. Okay, and then each element is composed of unique atoms, and the definition for an atom is just the smallest unit of matter that still retains the element's properties. And atoms are going to be made up of subatomic particles, which we've got three of them: protons, neutrons, and electrons. And then we abbreviate those. We've got a P for protons, N for neutrons, and E for electrons. We do have some really high-powered microscopes that you can actually see atoms under a microscope, which is really cool. So on this view, we've got the oxygen atoms. The computer has colored them dark blue. And then we've got rhodium atoms, which are kind of a silverly metal in a light blue. So you can actually see these individual atoms, which is pretty cool. We have not been able to see individual protons, neutrons, or electrons, but you can actually see the atoms, which is pretty cool. Okay, so what the atoms look like: they do have a nucleus in the center, and in the nucleus we will find our protons. The protons have a positive charge, and the way I remember that is protons have a P and positive has a P, so that makes that one easy to remember. The other thing in the nucleus of our atom we have are the neutrons, and neutrons do not have a charge. They're neutral. So if you just remember neutrons, neutral, no charge, you can remember that one. And then orbiting around our nucleus will be the electrons. And the electrons have a negative charge on them. Okay, so electrons have a negative charge. All right, another important thing to remember, and I would star this in your notes as well, is that the number of protons that an atom has is equal to the number of electrons. So they're going to be equal in number. As long as the atom does not have a charge on it. If the atom has a charge on it, it would be an ion, which we're going to learn about in a little while. Okay, so as long as the atom is uncharged or a neutral atom, the number of protons is going to be equal to the number of electrons. Okay, and then here's just another picture of an atom. This one happens to be a helium atom. And here we've got our nucleus in the middle. And helium has two protons with a positive charge. And then in brown here, we've got our two neutrons, which have no charge. And the electrons, they have two protons, so they will have two electrons, so equal number of protons and electrons. The electrons are actually in a cloud, so they could be anywhere in this area zipping around. But for us, it's just easier to draw them as if they're orbiting around the nucleus in this electron shell. So that's how we actually draw them.